I wanted to go over another polynomial example, one where they're giving us what the function's overall degree should be, and then a list of zeros along with what the multiplicities of those zeros should be. And these are pretty easy to start. It's just all the little things that have to go into completing them, because you have to just keep on combining these things through distribution to get to your final polynomial. So, for example, wanting a function of degree 6 with -2 as a zero of multiplicity 3, 0 as a zero of multiplicity 2, and 2 as a multiplicity of 1. So I have, if -2 is going to be a multiplicity of 3, I have x plus 2 to the third power. If I have 0 as a multiplicity of 2, I'm going to have x to the second power. And then 2 is a zero of multiplicity 1, I'm going to have x minus 2 just to the first power. And so we could just start plugging away at this. I try and play with it a little bit. For example, x plus 2 and x minus 2, those are conjugates of each other. When I multiply them, I should get a difference of squares. So I'm really going to think about this as x plus 2 squared. I'm going to have an x squared and just an x plus 2 and an x minus 2. X plus 2 times x minus 2, because they are conjugates, will just distribute out to x squared minus 4. I've got this x squared here. I can go ahead and do this multiplication as well, which would be x plus 2 times x plus 2. And remember, with multiplication, the order with how we start to distribute does not matter, because multiplication has that associative and commutative property, so I can just reassociate them in any way that I like, so I can just kind of clean this up as I feel like I want to. So this is my function. I forgot to label it to begin with. Continues to be my function. Oops. If I multiply x plus 2 times x plus 2, I should get x squared, a 2x and another 2x, so 4x in total in the center, and 2 times 2 will give me 4. So that's these two combining to give me this polynomial. These two combined to give me this polynomial. These two I can combine just through distribution. X squared times x squared, so this one right here, would give me x to the 4th. And x squared times -4 will give me -4x squared. So now I'm down to having to distribute this trinomial with this binomial, and again that just means distribute every term with every other term. So x squared times x to the 4th gives me x to the 6th. X squared and 4x to the squared will give me -4x to the 4th. Then I move on to distributing that 4x. 4x and x to the 4th will give me 4x to the 5th. 4x and -4x squared, -16x to the 3rd. Then 4x to the 4th. And -16x to the 2nd. So this is what it looks like. Now I need to clean this up by combining my like terms. So my function is going to equal x to the 6th. I have 1x to the 5th term, so plus 4x to the 5th. So I've taken care of these two. I like to cross them out as I go so I don't forget anything. -4x to the 4th plus 4x to the 4th. Those x to the 4ths cancel each other out, and we're just not going to see them here because they're exact opposites. So there'll be no x to the 4th term here. Minus 16x to the 3rd minus 16x squared. So this would be our overall resulting polynomial. Sometimes they don't go quite as quickly as this. Like I said, our job is just keep plugging away at doing that distribution until we've had all of our polynomials just completely distributed out with the others, as we're pulling these factors together through multiplication to get them to their kind of traditional polynomial format. I hope that helps. Please keep sending questions.